Okay, so this is a continuation of lesson 12.2 that you guys saw the other day. So I'm not going to go through the whole explanation. I'm just going to go through examples. This video is going to be broken up into 3 different parts, each part covering each of the examples. So some of this will be a review that you saw yesterday, and you're more than welcome. The first video will basically just be a review of what you saw yesterday with a couple more examples, especially for period 1. Video 2 will be with the shifts, and video 3 will be with completing the square. So let's go through example 1. So reminder on how to do these. So the first thing we want to do is we're going to do a quick little sketch. Now what I'm going to do is I'm actually, as I was doing this with the other classes, we found that I found that a little bit easier for students if we just graph the given information on the coordinate grid that is given. So in this case, I'm going to go graph my focus and my directrix. So I have, let's see, I'm going to do this in red. So I have my focus at -8, 0. So here's my focus, and my directrix is at x equals 8, which I'm pretty sure is right here. Now, I'm then going to plot my vertex. My vertex is right, so there's 2 ways of doing this. One is they tell us the vertex is at the origin, but even if we did not know that the vertex is at the origin, the vertex is right in the middle between the focus and the directrix. So in other words, the vertex is going to be right there at the origin 0, 0. So next, as we did the other day, we're going to do we're just going to do a quick little sketch to figure out, is it opening horizontally or vertically? So reminder on how to do that. So when I graph this, there's 4 different ways this could open, this parabola could work. It could go like this, it can open up like this, it can open up like this, or it can open up like this. What I want to do when I graph it, I want to make it open up in such a way that it would never cross the directrix. So, in other words, getting rid of those ones. If you notice, there's only one way, I'm doing this lightly in orange. There's only one way that I could graph this such that it would not cross the directrix, right? If you look at this graph, when it extends in both directions, it will surround the focus. It will not touch the directrix in any way. So this is a horizontal parabola. So now we go to our formulas, and I'm not going to keep on doing this. I'm just going to do this one time, and I'm going to look for the one that's horizontal. So let's see. Oh, this is my horizontal formula. So let's write that down. So horizontal formula is 1 over 4p y squared equals x. The next thing we want to do, now that we've chosen our formula, is we want to figure out what is p. P is the directed distance from the vertex to the focus. Okay, it is the directed distance. So in other words, I'm going to go from I'm going to do this in pink. I'm going to go from my vertex to my focus. P is that directed distance. All that means is it's my signed distance. So in this case, because it opens to the left and I go 8 units, the directed distance, or P, is -8. So I'm going to plug in P, -8 for P. And from here on out, we just clean this up. Sorry, there should be no square there. Okay, so that is our parabola in standard form. The next thing we're going to do is we're going to actually do a nice graph, because again, the graph that I made was just a quick little sketch to give me an idea of how it was opening up. So we're going to make a table. All I need you to do when you make this table is you just need to choose 3 points, with one of the points being every single time 0, 0. So because this is horizontal, my independent variable is going to be y, and then I'm going to be having x for my parent function, and just like we normally do, and then I'm going to be taking that x and multiplying it by the stretch. Okay, so remember, independent, this is our normal values for our parent function. This is going to be our output values. So let's see what we got. So I'm going to plug in, since I'm only choosing 3 numbers, I'm going to plug in -4, 0, 4. So based on our parent function, those would become 16, 0, 16. Multiplying those by the stretch value, -1/32, I would get -1/2, 0, and -1/2 again. So the way we read this, remember this is horizontal. So I'm going to do this in 2 columns. My pink column are going to be my x coordinates of each point, and my green column are my y coordinates. So the points I'm going to be graphing on here are -1/2, -4, 0, 0, which is already graphed, and -1/2. Oops, that's a -1/4. -1/2, 4. So those are going to be the 3 points that I'm going to accurately graph. So let's go and do that. So our first point, 0, 0, is already on there. -1/2, -4. 1, 2, 3, 4 is down here. And then 1, 2, 3, 4, the other one's right there. So my graph is going to actually look like that. This is kind of difficult to do. So something like that. Okay? Let's move on to the second one. So for these next ones, what I'm going to do, because we've already gone through this, I'm going to kind of, for each step, I'm going to give you a direction. I'm going to pause for a couple seconds so that you get time to pause the video, go through and do the step, and then you can kind of start playing the video game, and I will catch up with you. So the first thing that you should do right now is make a quick sketch on your coordinate grid and determine which function or which formula you're going to be using based on the orientation of your parabola. So do that now. Okay, so I'm going to go through and do that. So I'm going to plot my focus. My focus is at 0, -2. And then I'm going to plot my directrix, which is the line y = 2. And then finally, I'm going to plot my vertex. Now remember, the vertex is smack dab in the middle. So my vertex is right here. Again, they tell us that, but we could have figured it out anyway based on definition. So our graph, just by looking at it, I'm going to erase this time just because it interfered, but my graph is going to have to go something like this, right? So that it doesn't cross my directrix and it surrounds my focus. So in other words, it's vertical. So the function that we're going to be using is going to be 1/4p x squared equals y. What you should be doing now is figuring out the value of p and writing your formula, or writing your equation. So why don't you do that now? Okay, so again, p is the directed distance from the vertex to the focus. In other words, from the blue point to the red point. That directed distance is -2. So I'm going to get 1/4 times -2, or 1/8. At this point, it's time to graph it. So what I want you to do is go make a table, and graph your function. Okay, so I'm going to go and do that, and I'm going to be choosing 3 values. Again, all you need to do is choose 3. In this case, it's going to be x, y, and -1/8 y. So I'm going to choose, I think I'm going to choose my normal, -4, 0, 4. Again, make sure 0 is always one of them because you've already plotted it anyway. Make it easy. So squaring these, I get 16, 0, 16. Taking -1/8 of those, I get -2, 0, -2. So the graph of this, and I'm going to go a little thicker on this. So the graph of this is going to look like -4, -2, 4, -2, and then we go and make a nice parabola. Make sure it's not a V. Please make sure it's a parabola. So something like that. Okay. Again, every graph should have your vertex, your directrix, and your focus on it. Okay. Let's move on to the next. So at this point, what I want you to do is I want you to do number 3 completely on your own. And then once you've finished, unpause the video. Okay, so let's go through this. So as usual, I'm going to figure out the orientation of the parabola. So I'm going to plot my point. So first point I'm going to plot is the point 2, 0, which is right here. And then I'm going to plot my directrix, which is the vertical line x equals -2. Okay. Now I'm going to make a quick little sketch to determine which way it opens. By this point also, you should kind of know which way it opens without having to sketch it, but you're more than welcome to sketch it. Oh, I did forget to draw my vertex though. My vertex is right in between. There we are. So again, you don't need to do the quick sketch if you already know which way it's opening, but if it helps you, please do. I see just based on my quick little sketch, it's going to open up like that. It's opening up to the right, so it's horizontal. So now that I know it's horizontal, I can choose the appropriate equation. So let's go and do that. So a horizontal one is of the form 1 over 4p y squared equals x. And now I'm going to figure out my directed distance from the vertex to the focus, which is +2. So it's going to be 1 over 4 times +2, which is 8. And that equals x. Next, going to make my table. I may have to erase that table for when I go and do the second one. So let's see here. I'm going to be having y, because this is horizontal, remember, I'm going to have to kind of read this backwards. Y, x, and the stretch times x. Okay, so let's see what we got here. I do want to remind you just really quickly, I don't want it to be confusing, but x does, in this case, x just represents the function y equals x squared, right? So it's based on our parent function. It's not quite accurate for this. It's just a tool that we're using to make things easier. Okay, so let's see what we got here. I'm going to plug in my normal values, so -4, 0, 4. Squaring those for my normal parent values, I get 16, 0, 16. Taking 1/8 of those, I get 2, 0, 2. So the graph is going to look like this. So so my points are going to be 2, -4. And 2, 4. I hope that's right. Okay, and when you're finished, something like that. So last example for the first video. Please go through and graph it. Okay, so going through and doing our normal stuff here. I'm going to go plot my vertex. So my vertex is at 0, -1/2, which is going to be kind of rough because I'm going to not change units just because I'm going to be stubborn here. The directrix is at y equals 1/2, which is there, which means the vertex is right in the middle at, of course, the origin 0, 0. So this one is going to open down, so I know it's going to be a vertical one. So let's get rid of that, and let's go write down our vertical equation. So our vertical equation is 1/4p x squared equals y. P in this case is our directed distance from vertex to focus, or blue to red, which is -1/2. So it's 1/4 times -1/2, which is -2. Making our table. So we have x, y, and our new function, -1/2 the y value. So let's see what we have here. I think I'm going to choose some different numbers here because, yeah, I'm going to choose -2, 0, 2, because I'm a little concerned about it going off my graph. So I get 4, 0, 4, multiplying by those by -1/2, I get -2, 0, -2. So our graph in this case, we get, what's that, -2, -2, and 2, -2. So our final graph will look like that. Okay, see you in the next video.